All right. Hope everybody's doing okay. Um, let's talk about the chain rule here because this is very essential when you are taking derivatives because derivatives really tell you a lot about the equation at different points. So they talk about the slope. And the chain rule is one of those things that you talk about the composition of more than one function, or just say two or more functions. So I want you to think about like f of g, and that's a composite function. So f and g were two functions, and we were to put them together, they would form a function inside of a function, or you can have an h, I, j, k, and all those functions can make one big long equation. So think of it like fog is equal to this, and the whole process of this, when you take the derivative, so when you take the first derivative, so dy dx, you're going to do this chain, what we call the chain rule. And it's like a function inside of a function. So we're going to say, okay, well, we're going to take the dy or with du times du over dx. Now, this is what was in a calculus book that it would describe as a chain rule. But if you think about it, you're going to make like a u substitution and you take the derivative with respect of that function and you would plug stuff in. So we can do that along the way. But anyway, to kind of familiarize with this, if you take the derivative of this composition, you're going to have that y prime is equal, well, you're going to take the derivative of the outside, which is f. So you're going to go f prime. And then what you're going to do is keep the stuff inside. So like your g of x, may use a different color here. So you're going to keep that part there because that part's like the, I don't know, the inside of the function. Then what you're going to do, so since you did that, you took the derivative of that, you have that. Then remember, you're always going to go, okay, times the inside function. So times the derivative of the inside function, which is going to be g prime of x. And so your function turns into this. Now, what you have to watch out for is sometimes there's going to be a little power right there. You have to be careful with that power. You also have to be careful about what if this had multiple. So let's say that you had something like g of h of x, and you have three functions here. And you have to take the chain rule of that. So you would do y prime, which is what's the derivative of the outside? So what's the derivative of the outside? Well, the outside function is going to be f prime. And so you're going to leave all the inside functions. I think that's enough parentheses. Then you're going to multiply, well, the derivative of g. So that's going to be g prime, h that. And then you're going to take the derivative of the inside function, which is h prime. Now, the thing is about this is that you're going to go from outside to inside to inside. And what you're doing is that, according to the chain rule here, it says you take the derivative of the outside, keep the stuff inside. And that's the process with this. You're just kind of going from outside, keep inside, derivative of inside, keep the insides if there's insides to it, and just kind of work yourself out, or outside in, I should say. So let's do a couple examples. Maybe this will sink in enough times. But here we go. So let's say you have this example here. Pretty straightforward. Now, what I would recognize you to do is saying, okay, well, what if I said f is going to be x squared plus 4x. Okay, there's my first function. And kind of what I'm doing is kind of looking at this up here, f and g. And then what's my g function? Well, my g function, it says, well, what else do I see here? Well, I see that this is embedded with a 5. So maybe this will be like x to the 5th power. So think of it this way. That is that. This is the inside. There's the junk. Now, what I'm going to do is just take the derivatives of these. So what if I take the derivative of this? Well, if I take the derivative of this, this is g prime of x equals going to be 5x to the fourth. Okay, so that's not a chain rule. That's just simple doing some, dropping some exponents. Now, what if I take g prime? Well, g prime of x is going to be, well, this is 2x to the first, that's fine, plus 4. And that's it. So now you have the derivatives. What I'm going to do is kind of follow this pattern up here and put them together. And so this is kind of what the chain rule is asking you to do. So I don't know if you see this or not, but what's the outside function? Well, the outside function, isn't it this one? Isn't that the outside function? So when I take that derivative, which is this one, it's going to be y prime. And then it's going to be, okay, this is the derivative of the outside function. So this is going to be 5. What I'm going to do now is put a parenthesis and then put 4. Do you see why I did that? If you don't, when I did this derivative, this part that's the x is this. So what you're going to do is take this and plug it there. So this is going to be x squared plus 4x plus 6. So this is still the inside of the function. The outside was this one. And then the inside still has that. Now, I'm just going to go ahead and continue on. But I already know this derivative because I calculated it right there. So this derivative is going to be 2x plus 4, which is that one. Now, what you should be able to do is combine stuff together. So I'm going to finish this off saying, okay, I have that y prime. This is multiplication. I don't want to touch this part here because one is that is embedded into that, but that 5 is just going to be out there. So I'm going to actually just go, well, that's multiplication. So I'm going to go 5 times 2, which is 10. The x is going to follow. The 4 doesn't do anything. But now I did 2 times 5, which is that, times x. But now I'm going to go ahead and put this extra piece here because I'm not going to touch this piece. Oops, I think that's right. Plus 6 to the fourth plus 4 now. That is the derivative. Now, what I would do is not go any further than that. I will expand this out. It's just a waste of time. But as long as you are getting to the derivative, you're fine. Okay, let's try this one now. Looks pretty easy, but I hope that you can see why you have to use the chain rule. So the f function, I don't know if you can see it or not, is that one. It doesn't matter what f and g are, by the way. And then g is going to be the stuff that's inside. So there you go. So that's one way to see, hey, I have multiple functions. That's a chain rule. Now, what I could do is take the derivative of both of these if I really wanted to. So we could, but I'm going to just do it all in one package here. So here we go. Now, since you have a d and an x, I'm going to go ahead and go dy dx because it's in respect of, y is in respect of x. This is going to be the derivative, but what I want to do before I even do that is come back down here and say, well, okay, what if I rewrite this as x squared minus 7x all to the power half? Do you see what I did there? So before I even start taking the derivative, I want to say, well, what if I rewrite this radical as a power? Because it makes it easier to do. That's just a proper etiquette for this. Now you're going to say, okay, now I'm going to start here. I'm going to go right there. So sorry, there's too much here. Let me erase this for you. So you kind of go down here, you rewrite this, and then now you're going to start taking the derivative. So like I said, you should see these here, but before I take the derivative of these two, this is a chain rule. So here we go. This is the inside. Do you see the outside function? There's the outside function. So we're going to take the derivative of this. So this 1/2 is going to come in front. The stuff that's inside is technically this minus 7x. Do you remember what we do with this exponent? If we plug it down there, we're going to subtract by 1. So it's negative 1/2 because that's 1 minus 1. So that was this one. Now it says take the derivative of the inside function. So we're going to take the derivative of this, the inside. So you're going to multiply, and we're going to go, what is it? 2x minus 7. Now, I would be careful here because there's so much going on because you don't want to do too much. This is 2x minus 7. So just be careful with this because there's not a whole lot we could do to this. If you didn't put the parenthesis and put a multiplication, I think you're okay. But I'm trying to kind of refer back to this one because this one was all multiplying. So we got to be very careful. So I think that is just a derivative. So I don't want to jump to conclusions here, but remember that is embedded into that. So don't go ahead. What you could do is change this a little bit. You can make this positive if you want. So maybe we can do that real quick just to kind of see how this works out. So let's do it. So let's go down here. I'm going to take the half and I'm going to go 1/2. I'm going to take this and go 2x minus 7 because this doesn't change. The only thing that does change is this piece here goes down there. So this is going to be x squared minus 7, and I'm going to go ahead and do that. And I hope that you see why I'm doing that. Think back to this one. Remember, this one was x to the half. So now what you could do is say, oh, this is 1 times that. So you're actually can do some more work up here. But like I said, I don't know how far you want to go on these. You should simplify as much as you possibly can. So I'm going to go set 2 minus 7x. This is going to be that minus 7. Now, I know what you're thinking. Can you cross those out? No. That's why I didn't kind of do it here. I just want to make sure we're doing it correctly here. Okay, so I think that is that derivative. All right, let's do another one here. What if you do something with some trig? So it's the same procedure. Don't freak out, but you might want to write a little note over here and just in case. So for example, we might want to say, okay, we have sine of x, and that derivative, if there's that, is going to be the derivative of sine is going to be cosine. And then we have cosine, and its derivative with respect to that is going to be negative x, or negative sine x. So you might want to look at that, put that in the back of your head a little bit. So let's go over here. I know that some students don't realize that you can actually rearrange this. So here's what I mean by this. So what if I take this 3 and go sine of x to the 3rd power? That is the same thing. And if I did cosine x to the 3rd power, it's the same thing. This part here is just proper. So now, do you see the chain rule? Do you see the chain rule here? We're gonna have to do the chain rule twice. Don't know if you see it or not, but this is a function with that. So over here somewhere, you might want to say, okay, well, I see this, but look at this way. I see that, and I kind of see that. Do you see it? Okay, so you kind of have that. This is called the chain rule because you have 2 functions. So here we go. We're going to go dy over dx. This 3 is going to kind of come downstairs. I probably shouldn't use a pencil. This 3 is going to sit there. We're going to keep this piece here, which is sine x. But now be careful here. Since this 3 came down, this is a 2. And I would advise using more parentheses here just because it's a grouping symbol. So I'm going to kind of maybe just let it go. But okay, think of it this way. This is still the inside function. We took the 3 down. We kept the inside. We replaced the 3 with the 2. But now we have the derivative of sine, which is cosine. So this is going to be cosine. Okay, that's the first derivative of that one. We still have to deal with this one. So I'm going to put a little plus here. And now I want to deal with this one. Same process. So this is 3, but cosine x squared, because that's from that, times, well, the derivative of cosine is negative sine. So what I'm going to do is put a parenthesis and go like this. And there you go. But what I'm going to do now is simplify this a little bit, make it look nice. So this is dy dx. This is going to be, well, let's see, 3 sine squared x cosine x plus 3 cosine squared x sine x. Now, I know what you're thinking. What about that negative? That replaces that. That's right there. That is its derivative. It looks like a nightmare, but it is what it is. I saw it. Okay, look at number 4. Do you see what's going on here? Over the side here, so let's see. One of my functions is I have that one. Maybe another my function I should actually use f and g because technically we've been doing f and g. G, do you see G? Well, I have that. Let's do H. H is going to be the other one. Do you see? So you have 3 functions into one. So that's a chain rule. And this one is the deepest. This one's the second deepest, and this one's the outside. So this one's the 1, 2, and 3. So we're going to start on the outside, which is 3. Here we go. So dy dx, because you have the x with respect to y. Now you're going to go, okay, the derivative of the outside. So that 2, remember that 2 is going to sit downstairs. It's going to be sine. I'm going to keep everything here because it's inside sine. So I'm going to go cosine 4x. Now, if you want to put a 1 right there because of that 2, that's fine. Times that one. Okay, so now working here. So the derivative of cosine is that. So just go ahead and do it later. And the inside function stays the same. So that was that derivative. Now you're going to take the derivative of that, which is 4. You see how we did that? We went from that, kept that, kept that. Clean this up a little bit. This is all multiplication, so you can't really go wrong here, but there is a negative there. So that negative goes there, and you go 4 times 2 is 8. Sine of cosine 4x, sine of 4x. I think that should be your answer there. Cool. So the chain rule is not a bad thing. You just got to practice more and more. But you also, a couple things going away is that you have to recognize that, the function, and how many you have. And you have to kind of know what to take as a derivative. And like you remember, you have to kind of remember the quotient rule could play into this. So quotient rule could play into this. You might have the product rule that plays into this. So let me do one more for you. Now I know this one looks bad in this one, so I'm just going to go ahead and do one of these, and you can try the other one on your own. So here we go. Let's do a quotient rule. So this is a quotient rule. Do you see the functions? This is a function inside this one. So over here you got x to the third. And then this is going to be x minus 6, x plus 7. So those are your 2 functions. I hope that you can see that from this. Now what we're going to do is we can, if you want to, you can separately take the derivatives of these. So I'm going to do that. This is pretty easy. So I'm going to take the derivative of that. So if I take the derivative of that, that's dy dx, and that's going to be 3x squared. Okay, so that's the derivative of that one. Pretty easy. Now I'm going to take the derivative of this one. And this one becomes a little bit more complicated because that's a quotient rule. So over here, you might want to write, okay, f q prime equals g prime, that and that, right? Low d high, high d low. So here we go. We're going to take the derivative of this. So this is going to be kind of fun here. So you can start at the bottom if you want. It doesn't matter. So x plus 7 squared. Now on the top, you're going to say leave g. Hope I have enough room. Leave g alone. So g is the bottom. So you're going to go x plus 7. Take the derivative of the top. So the top derivative is going to be 1. Minus. Leave the top. Put a parenthesis. It does help. Minus 6. Take the derivative of the bottom, which is going to be 1. Don't know if you see that or not. It doesn't look too bad. Clean it up. If you want to expand this, I don't know. You don't have to. You can. It's not that bad, but we're not going to do it. Let's see. That's just going to be, oh, that's easy. Was it x plus 7 minus, c. Be careful here. Be careful. Boom, boom, right? Boom, boom. So that's going to be negative plus 6. Yep. Okay. Let's clean this up a little bit more. X plus 7 all squared. Looks like we're going to have nice. Oh, that looks 13. Okay. That's the derivative of this one. So this one is 13x plus 7 all squared. Hey, there you go. We're not done yet. We took the two derivatives, but now we got to put them together. So here we go. What is the derivative of this? Well, you're going to take this one. This is the outside. That's the outside. So we're going to take that derivative, which is this. So here we go. dy over dx is equal to 3 parenthesis squared. So you're going to put x minus 6, x plus 7 times the derivative of this one now. Of this one. This one is the inside. That one's that. So this is 13. This is x plus 7 all squared. Now, it's just all simplifying. I don't know how much you want to go through this or not, but here we go. I'm not going to touch this. I mean, you could put the 2 there and there. I don't know. I don't know if I want to worry about that, but I can actually multiply the 3 and the 13 together. So what is that? 20. So let's see, that 13 times 3 was that 9, 39. So this is going to be 39x. Let's be careful here because can't do too much here. That times this. I'm actually going to get rid of this because I think that this is going to be a no-no here. This is the part you have to kind of watch. So this and this would be 39. I know that. And then that's 39. That's going to be that. That's going to come down there. I don't know how much I want to do here. You know what? The whole point of this project is just to get to the derivatives. Okay. I hope that this made sense. Try this one. This is like your F. This is your G. Okay, try that one, and hopefully everything works out in your favor. But the chain rule is not a bad thing. It's not a bad derivative, but it does take a lot of deductive reasoning, or you have to watch your steps. Attention to detail, I should say. All right, hopefully that works out, and keep learning.